Okay, let's continue interactive tools, which is related to the machine learning. We already dive into some of them. So you can, I already put, you can try, just I'm explaining the important one. So there is one more interesting tools, which is based on the web-based environment developed by Google. User try to create drawing quickly and easily and enhance drawing based on the AI. Suppose we draw like car. When we draw, the AI system try to suggest the car like this. You can choose you can another one, or suppose you draw something like that, and then system try to suggest you and improve your drawing. Or let's say consider human. When I draw, as you see the top menu, when I improve my drawing, can you see this border? And when I try to draw like this, try to understand, maybe this is the human. When I draw, border is bigger. See, try to guess who I am. Then still, unless I put the hair, showing other thing, but when I put the hair, try to guess, maybe this is the kids, like that. So this is that you can, this maybe motivate you to create new environment. Do not stick only this environment. Of course, you practice, connect to this side, but try to develop something new. But this developed by Google, but you can improve it, and that motivated you for your future. Open the new startup company, introduce new website, just little bit change the tools, then you will reach to the very good step. Okay, let's back to our slide, and you can try all of these one by one, which I tried the important one. So let's try to, this orange software we will touch a lot for hands-on exercise from now on. Orange, wonderful drag and drop environment. You can try many machine learning, which we already saw here. Most of this machine learning by simple drag and drop environment you can touch. So that is very wonderful and very easy. Then through the hands-on practice, Jupyter Notebook. And for who not computer science can enjoy this software a lot. Let's dive in the website and install the orange software. So what you need to do, you need to, based on your computer, Mac, or the type of your computer, you can decide. For Windows, I'm going to, for Windows, download it. Maybe installation, Avocado, you need to install as well. Very wonderful, environment. You can go for the Mac. and other platform which you need to Anaconda if you don't have. So try to oops. Just simply remember your computer name, local program, it will be orange. Many data set, you will, access through the orange, this folder, remember this folder. If you don't have a Anaconda, may ask you to install. For the orange is very wonderful. So while installing, just let me simply explain about the website, especially for a screenshot will be show you drag and drop function. For instance, for data processing, for let's say here you will see you just put your data and logistic regression and PCA. You can do it very straightforward. In the software I will explain, or this will be very helpful for you. You put your you can drop and drag and drop, put your all linear regression and random forest is machine learning. Remember random forest and logistic regression, and you will need to do some evaluation and then use it. We will practically do it, and this is the hierarchical clustering, and really wonderful, amazing. So we will discuss a lot today about this one. Naive Bayes, all of machine learning and deep learning algorithm is here. Some of them we will touch, and some the other you will try by yourself. But as much as I can, I will give you more explanation. Let me check, still not downloading finish. So this is ROC analyzing. So using the logistic regression and random forest together, and this is the ROC. I'm going to explain this one. This is very wonderful evaluation environment. Don't worry who doesn't have a computer or a mathematics background. Do not worry, I will teach very straightforward. So after installation, you see you can also paint the data. You can use the box plot, you may remember, and it's very wonderful. So there is many way to shows the data. If you use the Pagigorn is type of trees, but because in trees sometimes is many layers is confusing, but this sort of polygon based tree is very good for see the quality and understand the roots. So see, this is the trees. When you put the data, come to the classes, so we will see the, and there is a many concept here I'm going to explain later, don't worry. Just I'm quick reviewing before installation finish. So as you can see, like SVM classification tree, so this is coming confusion matrix I'm going to teach. So is like random forest, using the matrix, showing the result. What is the meaning of this? I'm gonna explain. So really wonderful. Yes, it is done. Maybe I stop the video until the program up to save the time. I pause the video. So it's coming now. Wonderful environment. See, so before coming the the environment, what is the orange? Orange is the open source data visualization machine learning tools. So that would be drag and drops interface. Very wonderful tools, very user friendly, great data visualization, and many hands-on exercise related machine learning we can do, as well as some educational hands-on an app you can add to the orange. So that would be great. So you can download through this link. And alternative installation in the Python, you can pip install Orange 3. This is possible. So Orange is flexible and easy to use data visualization, data mining, AI, data science, visual programming, open source, and the good thing is free, and you can develop through the Python. Wonderful. So one of university in Slovenia developed this software thanks to them. Really very nice environment. We appreciate their efforts. And some slide regarding the teachable machine. Already we did hands-on practice. So image classification, we tried audio classification, pose classification. So already we enough practice. So let's dive into software with some practical exercise. Okay, after running the orange, you can use the new one, or you could try to watch some video tutorial, as well as some example. So for now, let's try, and once you save any workflow, you can open it. So let's try with the new one. So this is, you can see many tutorial here, and in the YouTube there is many. I'm try to summarize it and teach you in a very simple way. So regarding the, usually you need to do input data. Sometimes you need paint data. For instance, if you paint data, means you similar the website already demonstrate. You can then scatter plot. Let me create the data. For example, C1. You can some data like this, or another data you can create. Variable x, for instance, you could say it was like size of something, and then y is the cost. You can simply close it. You can, whatever you did, you can save it as an image, or after, for instance, whatever you, this is the right click. Whenever you do right click, you can also bring from here, or mostly from here by right click, not click, right click. So data, this is visualization which you can see, for example, distribution, and model, which is very useful for us, trees like decision trees, random forest, linear regression, you see, logistic regression, naive Bayes, and neural network, deep learning, KNN, SVM, everything is here. Then you need to evaluate it. When you create the model, I will explain the steps of machine learning later, but just I wanna, grab your interest. ROC, I will explain. Confusion matrix, prediction. This is for evaluation. You already data you already created. This is just predict your model, but you need to evaluate it. So here you see, when we are talking about the model, mostly is the supervised. You remember, right? Those was the supervised. For unsupervised, like K-mean, HC, this is the example, PCA, and depend on type. PCA is unsupervised and K-mean. So let's do in a single way. Just right click, whatever you need, the scatter plot, you can put here. Drag and drop, you can bring from here. For instance, file, you can bring from here, or you can type. If you see here, if you don't see, you will type. For example, I need data table is like that. So you can click and delete. So if I bring paint data again, so you will see one number. So then you need to connect it simply. Wow. Then you can, play, very interactive. So as you see, the data I created here, this is a scatter plot. So you can change here is just for viewing, right? You see, if you want to change the legend, the data, labels, if you know the data, this is supervised learning, or sometimes in this the unsupervised learning, depend on type of data. So here there is some tools. For instance, you when you try to paint data, by mistakenly you paint here, you just select it and press the delete key, easily you delete it. If I press this one, I will delete data, whole data will be deleted. Magnet is very interesting. When you put, it seems there is a metal and magnet, data will be follow you, and that jitter just distributed data through the wherever you click it. So just try to see the magnet. See, is if I put this data come here, looks like, and then when I press this one, is try to distribute it randomly. If I press this one, fully deleted. So you can change here whenever, for example, boys, you can put the label for the data and then put the data here like this, or you can put the curves data like this. Whatever you do, you see the data in the tables. This is the value already created based on the coordinate system. Here is the 0. So 0 to here, 1. Then when you go to a scatter plot, you will see the result. And then here you can play with this, opacity of data. And now here is the cost, and here is the size. You can make it, change it, so you can play. So based on the classes which you defined. So many other tools you can interactively play and learn more about this one. Sometimes you can click and delete the link. Sometimes you input data. So some data which is in data set, can you see my here when I keep here? So this is the address, which is the data set. After orange folder, inside orange, so you can go inside. So many data. We will work more about the iris, the 3 flowers inside. We will work on it, and many other data, sample data. Suppose iris. Here you will see type of data. So as if I explain this data set, sepal length, pedal length. Do you know what is the pedal and sepal? So when you have a flower, this is the pedal, and the main flower has a small leaves, maybe like this. So this is the sepal, this is the pedal. So now trying to, when say the pedal width means here, from here to here, pedal length, this from here to here, and this is the sepal width and sepal length. Okay. You can change the dataset. You can use some URL, like some Kaggle dataset or some other dataset. You have a URL, you can connect it. You can, later on we will work on it. So this is the categorical data type, means based on the name of a flower. There is a 3-name flower, Setosca, versicolor, and virginica. And I have one image to show the difference. Yes, this is the sepal, and this is the petal, as I explained. So Setosca is the smaller sort of flowers, which is the sepal and petal is the smallest. We will see in the dataset. Versicolor is shaped like that, and virginica is like this. So already I did like that. Now I can connect this one to here. Now, not showing this painted data will be shows, the flowers. So here is the sepal, and here is the sepal length. So I can put petal length and petal width. So as you can see, the Setosca petal length is a smaller size and petal width is, so here a Veriska color is like that. You see, later on we will work on how this data set can differentiate it. For example, if you use as you saw, for instance, let's simply use the k-mean just for fun at the beginning. For instance, k-mean we can find from here, or you connect to your data and then this is the k-mean. So you can use the scatter plot. So this is the k-mean information, the maximum iteration based on the data iris data. So this is the result. So you can define color change based on the cluster. Shape is the cluster. Before let's see a data table, the result of the after k-mean done. You can see that cluster, C1, C2, C3, based on the input data. You see, if you want to see the input data, better data table, you open the data table here. This is the raw data. So raw data, one field is a categorical, means is the based on the category, is not the value based, but this is the value based. In the hands-on practice in Jupyter Notebook, first thing we need to do, we need to convert categorical to the numerical. We will touch that part later. So you see, this is the information of the those, but you cannot see category. When you do machine learning unsupervised, here when you do unsupervised learning is a k-mean. In data table help you to see the table, so cluster happen. So Iris Virginia cluster 3, versicolor cluster 1, and Setuska cluster 2. So through the scatter plot, here scatter plot of the main data is like that. You don't see about the cluster because data not running. This is the raw data. No machine learning algorithm implemented here. You see, but here, and you don't have any. You should just follow the instruction of the main data. But when you using the machine learning, then you will see the data change. So cluster data come here. So label you can define based on the iris raw data or based on the cluster. Shape can be defined based on the shape different. So here you see all shapes same, but here you can based on the size, based on the pedal width, this showing, as this visualization help you understand that this flower let me bring, like, you can make it smaller, put in side by side together, or you can use the window option. Just without pressing, keep the cursor, put this one, and then choose this one. And this is the orange. So here you can make a small size of window. You need to change because this is the size what we can do, not smaller than this. Okay, this is the minimum size we can do. So here you can see this is the, as you can see here, C2. To understand, you know, if you want to know what this data is, this is the C2. You just click, and when you click, can you see this is the highlighted? So this is give your record data. This is the Setuska, see the smaller. So, and then blue one is a C1, is the versicolor. So as you can see here, this is the smaller cluster, and then versicolor somehow is like this mix. So we will use different machine learning later on to differentiate this one. And this is the Virginica. So machine learning result is like that. And with the pedal width, you can see like this. You could say with the pedal length, similar with the sepal width. So sepal width, it seems that, what was the name, Setusa is a bigger one. Then, so you already saw the visualization. Now let's do for more interactive K-mean model, machine learning model. But when I try to use interactive, I cannot find. So that means I need to install add-on options. So in add-on options, for the first time, you can install the educational. Here already explained about the educational add-on options, or depend on your project, you can use Geo or many others which you can practice at, like bioinformatics, many information about the Geo dataset. You can try and see. This is the bioinformatic analyzing, plot differential genes, visualize diagram of the molecular interaction. If your major somehow related to the bioinformatics, that would be good, cluster analyzing. But in educational, you will see many K-mean clustering interactives, a gradient, you know, algorithm. So more interactive options. When you press some orange tree educational package will be installed. You just need to wait. Let's stop the video. Okay, this is finished. So saying that after installing add-on option, we need to restart Orange. So let's save it first. You can save your, for instance, like LABLect4 Orange. This is OWS. and then I need to quit, and then I need to open it again. Oh, sorry, not this one. Yeah, already saved this file. You just double click. Then I wanna see interactive. Yes, interactive came in already. So let's try. Let's using the some sort of data we have. Let's bring here. Let's make using this jitter some data here using the jitter. So we need to add, I can increase intensity when I press many datas come. So let's put some data here and some other data. Maybe data like this. This is the data already created. I can see the data table. You can connect to see data table how we created. So this is the data. So boys and girl data, not using the machine learning, just created. I'm going to use the machine learning, k-means machine learning, but the option here is interactive. So I connected. This is the interactive one. So if I use the normal k-means, so let's put, this is the iris dataset, but I used another sort of dataset. This is the unsupervised. So you just need again send the data. See very quickly when I connected data transfer. See very quickly. If data is big data, it takes a long time to show the data is loading to the machine learning. So this is the you can play with the number of classes and make the limitation with the number of classes. So here so let's scatter plot. So this is the all, this is the based on the cluster result, and let's see interactive came in. So you can see here showing 3 classes. So our data basically was 2 groups, but in 4 different classes. And if you see k-means, 4 class would be best, because when you go here, you will see the 4 class has more silhouette score. What is the meaning of silhouette score? Let's explain a very important factor to find the quality of the cluster. For instance, if one cluster here and one cluster here, one cluster here, if this cluster far from others means very clear and separated cluster, so silhouette score of this cluster would be high, but this cluster which is close to each other would be lower. And suppose there is two clusters very close to each other, silhouette score would be very low. So between -1 to 1, the silhouette score will be increased. So from so 1 is the best, means very far from the other. If technically explained, let's go to our slide. So in our slide, silhouette coefficient or score is a metric to evaluate performance of clustering algorithm. Value change from A, so what is the A and B? Let's first explain. So here you can see one cluster, and centroid point of this cluster, if you consider this point and the distance of centroid cluster to the other point in that cluster, your average would be A. And then from this centroid to the other cluster distances, average would be B. So maximum between A and B, suppose A and one cluster is very far from each other. Then if you consider centroid here, right? Then many points here, right? Close point or far point. Then from you calculate distance between this point to many, for example, point here. Average is A. So from this centroid to the other point, let's say showing by green, there is a point, other point, not from its centroid, from this centroid. So of course, when you calculate distance and make average, it would be B. So B, for this case, of course, is bigger than A, right? A here, B is too much. Maximum AB is what? Maximum is B, right? So that means this value you can show B divided to B minus A divided to B, right? And this would be 1, right? So this is 1 minus, since this is smaller than B, this value would be less than 1. So, and if the A is very small and B is big, this is going to be near to the 0, right? And 1 minus 0 means very far from each other. If B is very far, almost 1. So 1 is the best. But if this is the close, that means this cluster, for example, and another cluster. So centroid of this to the all point here with another point of so distance nearly A and B is close, and even A may be bigger than B. If A, B similar, this would be 0, and would be 0 means very close. And if A bigger than B means minus. In any case, this showing silhouette score is very great score to show how they clusters very well. I hope you get my point. Let's back to the here. Okay, so here showing maximum is 4. Why? Because the data we created, there is a 4 difference value, right? 4 difference value, it should be 4, right? So this is 4 is the best. And then here, based on the cluster, we set it up a scatter plot showing 4 class is the best, right? So we understood, because k-mean means is a unsupervised classification. Many time is doing and running and k number until coming to the best. So here, before go to the interactive k-mean, I would like to little bit show about the silhouette score, which is 4 is better. To do so, let's use the box plot. You remember, right? Bring showing by box plot. So, and set to the silhouette score, and then bring the this is the here, make it smaller for a different either girls and boy class or cluster. Let's keep for cluster. So remember, we have a 4 cluster and k-mean showing 4. So this is the value of silhouette. So if we increase the classes, then what would be happen? The silhouette value come down. So you see, this is maximum. If you cluster less, again come to less value. So see here, coming to the point 0.7. So the best would be silhouette score 4. So we can choose 4, and then also there is a one silhouette plot that would be great to show the silhouette value. You can use based on the cluster, and you see there is a 4 all cluster almost near to 1, because 1 was the good and 0 not good. Since our cluster, if we make a scatter plot, the result of the machine learning k-mean, these 4 cluster, and for all of them, for blue is separate from the other, and green and the yellow, all nearly is 1. Some portion which is close to the other clusters, so this area silhouette is low, so that's why you can see half, because this is close, but this area is separated from the other silhouette is good. Now let's see interactive k-mean. What is the interactive k-mean means? So let's this is the interactive. Let's put a scatter plot for be connected. So in a scatter, showing 3 cluster, right? 3 cluster. Data is same as our main data. See, our main data is same, but how divided is different. So partially get data from here and this one together, and put this centroid here. So put centroid here, and all is red. This data as a like this here, you see, and this data as a blue. Put the centroid here by default, and all this data, and very bad categorizing, frankly, and put the centroid here and whole tree cluster, so you can see. So let's see here. First of all, there is the recompute centroid. You can press many times, press until the system find the best centroid, best place for centroid, because you know that best if I before any computation, I can easily choose like this. I could say for the green data, centroid is this, and for this should be give data to this for red one here. If this data return back to green, this should be written back to here, because this is basically is like that. And this centroid should be if three, because this is decided three classes, because three centroid. We consider for three centroid, right? So should be like this is better. So should be move here, and this should be move here, and this red one written back here, and only red here, and centroid is here. This is the normal. The main data is like that, right? So let's see. This is computing. This is the interactive k-mean. Shows, because centroid always is very important in the k-mean machine learning supervised classification, to find main goal is the good cluster. So let's say compute one, see the blue come here, and the green went here, and red come to the mainland. If I press one more, should be return this data to the mainland. Is like colonizing. Some war happened. One more, yes, the data back to the main. But still this two is a red, but this should be go to mainland and remove after here. This come in the exactly center. Wow. If I press, if I back, show again, it was like that, remember? Then come here, come there, okay, great. So this randomize can randomize centroid like this, play different places. But whatever randomize, if you recompute centroid, so one more should be this. This is the best for that randomize, because centroid is very important. Wherever you put, there is possibility to change the cluster. So one more, if you put like this or like this, then this makes k-mean like this, either because this is very close to here silhouette of this silhouette is better than this, because silhouette of these two is less than 1, and sometimes they mixed. If I randomize again like this, so whatever you do randomizing, but after running the k-mean, mostly is like this or like this. In one cases, these combine together. Again, whatever you do, because this is silhouette is small. Okay, now I am going to teach one more point. Why? Because this is interactive k-mean for education. Before add-on installation for education, we couldn't find interactive k-mean. So this is for education. So I can move, instead of randomly, I can move by myself. Put here, put here. But whatever I do, putting when running computing the k-mean, similar. Either together these two or these two, nothing change. Even if I move this one here, because go very far, this data centroid, some data the government cannot control them, and then this will be go another government find. If I move centroid here, I think they will be back to the blue. See? Oh, sorry. See, back to, because this is very far. Now, if I close to the here, and some come. If I go here, some value come from blue and red. If I go here, some data and probably some, yes. If I put here, some data come here, but they will lose the mainland because far from here. But now it seems this manage this, but this is not usual. After computing k-means, this will be corrected. See? Again, same result, almost. Either this is together or together. And because silhouette of this is very big one, so you will see always separated cluster. Very nice. Orange is very nice, interactive, software. I think instead of talking and talking, you can understand the meaning. So I would like to also, before finishing this part, I would like to teach one more. Here, based on our, silhouette score consideration, we came to know should be 4 cluster. But basically, interactive start with a 3 cluster. But now I know should be 4 cluster based on that k-mean silhouette plotting. So I want to push this data set. You must have 3 data clustering. So I will add one more here. If I click one cluster, one centroid means 1 cluster. So I push the data set, you should have a 4 cluster based on the silhouette analyzing. If I one more time click on this centroid, it will be deleted. This will be added and deleted. Then see what would be happen. Now is a 4 cluster. I push the data set that you should have a 4 cluster. See, easily 4. And even though if I do randomizing, the result would be 4, always. Because I have a 4 cluster. Any randomizing, the result would be 4. Very nice, wonderful. So, let me teach you more with where is the here, okay. So already you saw this one and this one. We already now change it to 4, right? 4 cluster. Then this is also changed to 4. Before was a 3, right? The result of this. So you see how machine learning algorithm AI, we make AI. So let me, one more interesting section. This is the data, is a painting data, right? And interactive. So let's bring to here. Okay. If, please pay attention. If I add a new data set, for instance, I want to add one more data set here. See, the data appear. And one more boy, this is a class, this is the cluster. I have a 2 class, 4 cluster, but now is a 5 cluster. So let's add one more here. See, here if I do computing, I know it should be better 2, 4, 6, but I'm a little bit, because this is close together, I cannot say until I check the LABLed score. But let me finish this one. Yeah, this is the maximum, saying 3 cluster, right? 4 cluster. But I need to come back to the check the here, because data set already changed, right? Now I need to check LABLed, but this is, it is 4, it is fixed, but I want to check LABLed. Yeah, LABLed 6 is better. Maximum LABLed score. Wow, 6. So now I choose 6. So here you see 6 classes as a came-in result. But this 1, 2, 3, 4 classes. Why? Because this is interactive came-in, not automatically set it up. I have to teach. This is automatically machine learning running, right? And LABLed checking, it is okay. Here, C4. But here, showing, showing different. So this is interact, but this is right, because this is main machine learning. This is interactive for education. So then what do I need to do? I need to, this is 1, 2, 3, 4. I need to add 2 more. Of course, this is good, and this is good. Now I add 6. So whatever I do, even any sort of randomizing, even by myself move, if I do like this, because 6 classes, the result would be, see how trying to come to the, very good. I think now I already explained everything. Now you understood the came-in result. Okay, that is great. I think for now is enough. We will back to the orange software again. For now, we already try to see many sort of data changing, and yeah, that is great. If I put one data table here, data table here, and connected to the here, this is the raw data, only size and cost, and boy and girl, 2 class, that's all. But after running the machine learning successfully unsupervised, unsupervised learning, which I explain here, came in group similar item is a data driven unsupervised. So all of this you can do by orange. So this would be assignment. I will explain more. Similar, you need to choose one. Machine learning, just using the very interactive and very wonderful tools of the machine learning of the orange, you can try to learn many things. What I did, only using k-mean and explain many things. So here, only these classes, but here, see, let's compare. This is the raw data. So machine learning add cluster to the data and syllabate. So syllabate has a meaning, as I mentioned to you. This cluster 0.7, close to 1. It is good. Good cluster. Good cluster means separated from others. So most number is good. Even in the syllabate plot, we already saw minimum is the 0.5. So 7 is better. Mostly they are good. So you can sort it. So this cluster is not good. So maybe we can show it in the scatter. Yeah. I think the best way is see on the map. That would be better. Let's go on the map here. So if you see here, as I explained, some point which is close to each other means syllabate score should be low. Let's check it out. Can you guess what is this syllabate score? Should be very low. Maybe this part which is far from should be 0.7. Let's check it out. Yes, can you see? Is a syllabate is a 0.7, but here should be 0.6 exactly. See, because it's very close. Here in the middle should be 7. See, all is 7 because I choose many number. But close to the other cluster, syllabate score is 6. And this one, yes, this is 0.5 because it's almost near to the other cluster. Yes, 0.5. Very nice. Great. So let's back to the slide. So we already talked about this one. Yes. Now let's talk about the machine learning, machine learning pipeline workflow means if we want to make and create machine learning, any sort of machine learning, like supervised, unsupervised, reinforcement learning, we already touched with the orange. We did many hands-on exercise. So you will continue work with many others machine learning algorithm. So to do so, we need to to know what is the step to create one machine learning algorithm. So I'm going to explain pipeline from this data preparation and then modeling and then try to training and evaluating. So here you are. First, we need the problem definition. Why we need machine learning? Which sort of problem we are going to solve? Which sort of ML task we want? Either classification, regression, clustering, association, What is that? So we need to use some evaluation metrics to successfully saying that this model is okay. So like accuracy, precision, recall, ROC, confusion matrix. So then we can manage our problem. So during the problem definition means we define what we need and how we can get it. Data collection for a specific model and evaluation. So in the model, we need training data to train our model. In the evaluation part, we need the test data. So training and test, training for model construction and test for evaluation of our model. After data collection, it doesn't mean we create data. Sometimes we buy, sometimes we download, sometimes we clean data, clean existing data. And the other one is data splitting. We need for data splitting, a split data set in the separate set of training, validation, and testing. Means mainly training and testing. So basically, a training data set, we try to, so we have a data set, for example, 2000 data from real estate house. We divided two parts, training part, test part. So in the training part, also we have a two part, which is validate set. Sometimes we use this one for validate our model performance during the training. So this is part of training validation. So this is part of training, and this is the test. We want to test, so we don't use some part of data. Usually, for example, they set 70% of data set for training, 30% for testing. So this splitting data set, we split data set to the training and testing because we try to avoid overfitting our model. So we will talk later. And after that, we need to model selection. Which machine learning model we, after data processing, this is all is related data. Data. After our data is ready, we need to select about the model. We need to create the model. So construct model is this part, and this is the evaluation part, and next page as well. This is the after evaluation we need to deploy. So in the evaluation, we will use many criteria like accuracy, precision, recall, F1 score, ROC, AUC. I will explain later. For model creation, so we will use appropriate machine learning. Many algorithms we mentioned, right? Supervised, unsupervised, reinforcement learning. So we need to train our data set and tune parameters like k-means. Sometimes it's a k-mean plus. New sort of machine learning is try to optimize the location of centroid. And then a model evaluation by these parameters, which I'm going to explain. And after that, model deployment. And then when we create our model, we need keep monitoring, maintenance, retrain again, try to improve our data. So as a summary, ML pipeline provide a clear and organized approach to machine learning project. Now, little bit, because this part very important, and even in the orange, I will show you many times you will see accuracy, precision, recall. Maybe you need to understand the meaning of those, criteria. So let's dive in those points. So accuracy, precision, recall, F1 score, ROC. So can you guess what does it mean? What is difference between accuracy and precision?